All right, so this is Precalculus, Chapter 8, Section 3, the law of cosines. So we talked about the first two cases using the law of sines. So this is when we're going to use law of cosines, when we have side, angle, side, and when we have side, side, side. The formula for a law of cosines, the way I remember it is, it's the Pythagorean theorem. So it's got a squared plus b squared equals c squared. And then it has, with the extra minus 2ab cosine. And I always remember it's minus 2 times whatever you've squared, a and b, cosine of whatever angle is out here. So if you look at this one, it's a squared plus c squared. There's the a and the c. B's on the outside, b's on the outside. So that's how I remember law of cosines. Most of the time you're given it, and I would definitely have it written down. Okay, so when we look at our first scenario, our point up here, so if we're looking at coordinate geometry, if here's the origin, here's our point at the top. Up here, our x-coordinate is a cosine of c, because if we drop an altitude, it's a right triangle, we can use cosine. And our y-coordinate is a sine of c. We're doing this so we can prove the law of cosines. Our point out here, our third point in the triangle is b comma 0. If we had an obtuse triangle, these would still be a cosine c and a sine of c. All right, so the theorem of the law of cosines in words is a square of one side of a triangle equals the sum of the squares of the other side minus twice their product times the cosine of their included angle. So let's see how we apply this. Solve the triangle. A equals 2, B equals 3, and C equals 60 degrees. Step number 1, draw the picture. They're just going to give you this information. Make sure you put it down. Remember, little a, little b are across from angle A, angle B. Little c is across from angle C. So when you're looking at how do I put this together, make sure little a, which is 2, is across from angle A. Little b, which is 3, is across from angle B. And little c is across from angle C. So when we put together, we do not have the c side, so we want to get the formula with c squared on the outside. So we're solving for it. And then we plug the numbers in. If I'm doing this in my calculator, I'm probably going to do this part first, and then find this part, and then subtract the 2. Sometimes it gets a little confusing with this minus sign, so it's easier to have a number here minus a number here. And as you can see, that's the way they have done it here. So they're asking you for the exact answer, make sure you leave it in root form. If they're asking for an approximate answer, make sure you round it. We're solving the triangle, so we don't just stop at side C. We still need angle A. And they've used the law of cosines where angle A is being evaluated in the cosine. So you manipulate your equation and put cosine 2bc cosine A on one side and everything else on the other. So we added 2b cosine A and subtracted a squared. So it looked like this. And then you divided both sides by 2bc. And then you chunk all that together in your calculator and you inverse cosine it. And you get that the angle is approximately 40.9 degrees. So remember in Algebra 1 when you're like, why do I have to solve for the variable? That's stupid. This is why, so we can find angles. 3 years later. So now we have angle C is 60 degrees, angle A is 40.9. We use triangle sum to find that our final angle is 79.1. And our triangle is solved. All right, side, side, side. Side, 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 unfortunately, we're going to have to inverse cosine to find the angles. So the first thing we do is we solve for cosine A. And in fact, it doesn't matter which one you start with, A, B, or C. It's all the same. When we plug the numbers in, B squared, C squared, and A squared, boop, 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 and get a value, then we inverse cosine that, and we get that angle A is approximately 36.3. Now we use law of cosines to find angle B, so we do the same, just shuffle it around. And notice the difference between when I have cosine A, I got B, C, and A, and here I have cosine of B, I have A, C, and B. I inverse cosine that, and I get angle B is 26.4. And then we use a triangle sum to find that our last angle is 117.3. And our triangle is solved. All right, word problems. Remember, draw the picture on your paper. Anytime you have a problem, especially when it's involved, even redrawing the picture that they give you is going to connect neurons in your brain and help you solve the problem. So a motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds that after 4 hours, the sailboat is off course by 20 degrees. Here's that 20 degrees here. How far is the sailboat from Key West? Through what angle should the sailboat turn to correct its course? And how much time has been added to the trip because of this? Assume that the speed remains 15 miles per hour. All right, so we're going to law of cosines this. Our value here, let's see if I can get it to right. No. Doesn't want it right. This value here is x. We have 20 degrees as our included angle, 60 and 150. So we're going to find x squared. It's 150 squared plus 60 squared minus 2 times 150 times 60 times cosine of 20, because 20 is that included angle. That's when we chug that into our calculator, that's 9,185.53. If you're new to the law of cosines, please do the calculator application first. Make sure you're putting it in your calculator right and your answers are coming out correctly. Figure out your calculator before you go to a testing situation, because if you are not punching numbers in the calculator correctly, it's going to blow everything up. And each calculator is different on how, do they want it first and then you press the cosine? Do they want cosine first and then you input the angle? So make sure you have that first. So x squared is 9,185. So x is approximately 95.8. So that's how far away from Key West And then we are finding this obtuse angle here, so that we can turn and correct our trajectory. So when you do the math on that, it's 150 squared equals 96, because 150 is across from the angle we're looking for. 96 squared, that's this item here, plus 60 squared, that's this one here, minus 2, 96 times 60 times cosine A. So we add these together, and we subtract them, and we multiply these through, and then we divide by negative 11,520, and then we inverse cosine, we get this angle is 147.2. The sailboat should turn, so if it's this whole, we don't want it to turn 147 degrees. We want it to turn 180 minus 147 degrees, so it's going to turn 32.8, because this angle here is the 147, so it's going this way. So it's got to crank it that 32.8 degrees. So the total length of the trip is now 60 plus 96 is 156 miles. The extra 6 miles will only require about 0.4 hours or 24 minutes if the speed is 16 miles per hour. And that's it for today.